Hey yo there, what do you hear? What do you say? Synchron here, and today I'd like to talk about a really important topic in the philosophy of mathematics, namely, is mathematics discovered or invented? But before I get into it, I'd really appreciate a sub and a like. If you're able to, just take like less than a minute. And yeah, let me just stop the preamble and just get into it. So, an overview. Mathematics is deeply embedded in our scientific understanding of the world. It describes the orbit of planets, the behavior of quantum particles, and even the patterns in human behavior. But does mathematics have an independent existence beyond human minds itself? There are two opposing views that dominate the debate. There is a sort of mathematical Platonism, which is considered a discovery view, where mathematics exists independently of human thought and is thought to be out there waiting to be uncovered. And there is mathematical constructivism, which is this sort of invention view. Mathematics is a human-made system of symbols, rules, and logical structures developed to describe the world. And this debate has sort of profound implications for science, epistemology, and metaphysics. Now, obviously, there's more than these two views. There's Arialism, and there are views that don't really fit cleanly into both of them. But these are the two sort of broad camps. So let's just sort of expand on the discovery, the Platonistic view. So Platonism, this perspective holds that mathematical truths exist independently of human cognition, much like physical laws. It sort of goes back to Plato, although ironically enough, considering the sort of modern definition of Platonism used, Plato would not be a Platonist because Plato viewed, this is a bit of an aside, but Plato believed that the form is the abstractor. They actually could have some sort of causal powers in the world, right? Which brings us on to the sort of modern conception, which believes that mathematical objects, e.g. numbers, perfect circles, exist in an abstract, non-physical realm. Mathematicians do not invent mathematical truths, they discover them, much like astronomers discovering celestial objects. Obviously not in the same sort of way, it's using a different sort of toolbox. Mathematical realism is the sort of broader view. Platonism is a subset or a branch of mathematical realism. So mathematical realism, the broader view, is the sort of view that mathematical structures exist even if no human ever thinks about them. So, for examples, prime numbers are sort of inherent properties of numbers, not a human construct. And there are a lot of sort of arguments for this view, but probably one of the most prominent ones is sort of Wigner's idea. Wigner released a very, very famous paper titled The Unreasonable Effectiveness of Mathematics. Eugene Wigner, 1960, observed that mathematics, despite being an abstract discipline, applied almost miraculously to the physical world. That was his sort of terminology. Why does an abstract field like calculus describe gravity, or why does complex analysis apply to quantum mechanics? This view suggests that mathematical reality is external, objective, and timeless. The invention, the sort of constructivist view, is the view that mathematics should be sort of more viewed as a human creation. This perspective holds that mathematics is a symbolic system constructed by humans to describe patterns in reality. There are various sort of views that sort of espouse this, but one of the most prominent ones is formalism, and this was espoused by Hilbert in the early 20th century. Mathematics is a set of rules and symbols with no inherent meaning in and of themselves. Equations are sort of analogous to legal contracts. They're useful but not reflective of an objective reality. Another one is intuitionism, where mathematical, reality only exists within the human mind. If no one constructs a mathematical proof, that truth does not exist. And there are various arguments for it, but one of the more prominent ones is the case of alternative mathematics. Different cultures have developed alternative mathematical systems. Non-Euclidean geometry, one of the most famous ones, which will be talked about more, developed in the 19th century, challenged the notion that mathematical truths are universal. If mathematics was discovered, why would multiple contradictory systems exist? This perspective suggests that mathematics is an evolving human framework, not an independent reality. Let's focus more on non-Euclidean geometry. Mathematical truths as a sort of cultural constructions. This, on the face of it, might seem quite bizarre, but for centuries, Euclidean geometry was seen as the absolute truth. However, in the 19th century, non-Euclidean geometry emerged. Spherical geometry, on a sphere, triangle angles sums to more than 180 degrees. Hyperbolic geometry, where on a negatively curved space, triangle angles sum to less than 180 degrees. But this sort of begs the question, if mathematics were an objective discovery, why does geometry depend on assumptions? Mathematicians realize that mathematical truths are often relative to chosen axioms supporting the invention view. And there are various consequences to this, right? The role of culture and history cannot be understated. The dominance of Euclidean geometry for centuries was not due to its objective truth, but rather historical, cultural, and practical reasons and contingency, ultimately, such as its utility in architecture and navigation. sort of dependence on axiomatic choice. The validity of a mathematical system depends on the axioms we accept. There is no single universally true geometry, quote unquote, only systems that are internally consistent relative to their premises. Application-driven mathematics, non-Euclidean geometries were once seen as mere abstractions, but later became essential in physics, e.g. Einstein's general relativity relies on Riemann geometries. And another example would be number theory, which for centuries was seen as the sort of, mathematicians for mathematicians' sake, so to speak, right? It was viewed as just basically, curiosity, whereas now it's practically indispensable in cryptography and in the internet more broadly. It sort of undermines the discovery model on the face of it. If mathematics were purely discovered, we would expect a single objective system rather than multiple frameworks emerging based on different assumptions. Mathematics and axioms. Mathematical systems rely on a set of axioms which are assumed to be true without proof. However, different set of axioms lead to entirely different mathematical realities, with an example being geometry. Euclidean geometry assumes parallel lines never meet. Spherical geometry assumes all lines eventually intersect. Hyperbolic geometry allows multiple lines through a point parallel to one another. If mathematics were an objective discovery, why do its truths change based on the assumptions we choose? This suggests that mathematical structures are invented rather than found in an external reality. Another example, it might be set theory and the limits of mathematical universality. Naive set theory leads to paradoxes, most famously Russell paradox. Does the set of all sets contain itself? So the Zumulo-Frankel set theory resolves some of the issues, but isn't the only approach. There are alternative set theories, e.g. new foundations, constructivist set theory, but these redefine the sort of basic assumptions at the outset. The continuum hypothesis is that independent of the ZF axioms, this means that its truth sort of depends on the given chosen axioms. Now, all of this sort of belies the question, if mathematics were a universal truth, why do multiple incompatible foundational systems exist in the first place? The social construction of proof and rigor. Now, this will be an obscenely facile and brief history. This is basically me just going over it. And you should always keep in mind that whenever it comes to any of these topics, there's always more nuance, there's always more to discuss. So this is just going to be a very brief overview. So mathematical proof is often seen as the gold standard of certainty. If something is proved in mathematics, it is proved beyond all reasonable doubt. But what counts as a valid proof has changed throughout history. So, for example, in the ancient Greeks, the proofs that sort of were employed by Euclid and Pythagoras, these were based on geometric intuitions broadly and sort of axiomatic reasoning, e.g. Euclid's element would be the sort of paradigmatic example of this. There was a heavy reliance on visual diagrams rather than sort of strict symbolic logic. However, in the 18th and 19th century, there was an increasing amount of rigorization. There was a sort of shift from intuition to formal logic and formal symbolic reasoning in calculus, the sort of epsilon data definitions. And the concept of a limit, which was before sort of vague, sort of inchoate, sort of, a bit gray, so to speak, it became sort of strictly defined, eliminating earlier ambiguities. And then we go into the 20th century, where there's a sort of explosion in sort of logic and mathematics more broadly. So when it comes to formalism, Hilbert and his sort of contemporaries, the goal was to fully axiomatize mathematics, making proofs purely symbolic. However, Gödel's incompleteness theorem sort of threw a wrench into any of this. It sort of showed that any sufficiently powerful system contains true statements that cannot be proven within the system itself. And then later on, give or take a couple of decades, there were computer-assisted proofs, the four-color theorem and Kepler's conjecture in 1976 and 1998, respectively. These rely on extensive computations that humans just cannot manually verify in a reasonable amount of time. Some philosophers argued that they challenged traditional notions of proof by being empirical rather than deductive. The sort of key questions to sort of ask ourselves is that if mathematics is objective, why have proof standards evolved in the first place? If proofs depend on human conventions, is mathematical certainty a cultural artifact rather than an absolute truth? And so, in sort of summary, mathematical truths are deeply shaped by foundational choices, e.g. Euclidean versus non-Euclidean geometry, classical versus intuitionistic logic. Concepts like number, infinity, and proof have evolved, showing that they are not purely objective but influenced by historical and cultural shifts. And the history of mathematics suggests that multiple alternative paths could have been taken, meaning our current mathematical system is just one of many possible frameworks. Mathematics lies on a spectrum between invention and discovery. If discovered, why does it change? If invented, why does it seem so necessary and universal? And here's a sort of final reflection. Is mathematics the language of the universe, or is it just the most efficient tools humans have developed to describe it? Now, these are sort of my sort of rough sort of thoughts on the given topic. But again, I would love to hear your thoughts and your sort of inferences and conclusions in the comments below. Again, please like and subscribe. And here's a sort of list of my various sources that I've sort of read through and some further reading that I think would be quite helpful. So with that being said, this is Synchron signing off.